I'm very interested in research, and so I'm going to tell you a little bit about some of the research that I do. One of the activities in which we're very strong here in Leeds is star formation. And one of the big questions, of course, is how do you take material that's in a galaxy and get it to form a star? Well, let's start with the question, why is the galaxy flat? Well, the galaxy is flat because it has a lot of angular momentum, and that angular momentum causes a centrifugal force that prevents collapse occurring in certain directions, though collapse is able to occur so that you can get the flattened structure. Now, angular momentum, we know that the moon goes around the Earth, so that there's angular momentum there, and as the moon is going around the Earth, it keeps one side towards the Earth at all times, okay? And that means that the moon not only orbits the Earth in a month, but it also rotates on its own axis in a month. The same thing happens in the galaxy. If you have a cloud of gas out there that's eventually going to form a star, it rotates initially so that one face stays towards the galaxy center. Okay, so this cloud of gas is rotating on its axis every time the galaxy goes around, and that means that that cloud of gas has angular momentum. Now, to collapse, this angular momentum helps prevent collapse. To collapse down to a star, it turns out that you have to get rid of all but 1/100,000th of the angular momentum that the gas initially has. So that's a factor of 100,000 of angular momentum that you're losing. Okay, well, the amazing thing is that if you get rid of too much angular momentum, all you do is you get a star and no disk around the star. Okay, you don't get planets, and planets form in disks.